Okay. Brahan.
Present po.
Aliga.
Present po.
Alog.
Present po.
Anday.
Present po, ma'am.
Atienza.
Present.
Barza.
Present po.
Barza Kenneth.
Present.
Beruela.
Present po, ma'am.
Briones.
Present.
Kabali.
Present po, ma'am.
Kabatuan.
Ma'am, present po.
Kabatuan.
Ma'am, present.
Cappuccino.
Present po.
Dalisay Francine.
Present.
Dalisay Prin.
Present po.
Danila.
Present po, ma'am.
De Chavez. De Chavez. Dinglasan.
Present po.
Ebe.
Present po.
Evangelista.
Present po.
Galario.
Present po.
Gatdula. Gondra. Gondra. Javier. Nanditso.
Present po, ma'am.
Lumbres. Lumbres. Makaraeg. Makaraeg. Malabanan.
Present po.
Maligalig.
Present po, ma'am.
Manlapas. Manlapas. Mayo.
Present po.
Mendoza. Mendoza Nico. Morillo.
Present po.
Orias.
Present po, ma'am.
Panganiban.
Present po, ma'am.
Lata.
Present po.
Remo. Remo. Villanueva. Villanueva. Samyuj. Okay, so noted na lang, Kriza. May isa pa sa inyo, di ba? May isa pa sa inyo. Na walang index card.
Naman ka basis po.
So wala siya ngayon. Okay, so masyado bang maingay? Or okay lang?
Gusto maingay po, ma'am.
Pasensya na lang if ganon. Ano? Wait lang. Hindi gagawin dapat ako eh. Okay, so yesterday we discussed about madlagi. And then kahapon, nag-post ako sa classroom ng video about madlaging. So who can share about their thoughts and learnings about the video you watched yesterday after we ended our class? Anyone? Volunteer. Pinanood niyo ba?
Yes po, ma'am.
Mayo.
Ma'am, from watching the video po, the video is about what the Mandaluyos do sa drill site po and how they evaluate yung samples na nakukuha po nila. And then, napansin ko po doon na yung nakukuha pong samples from sa mga mas mababaw is dirtier. Tapos pag linis po and pag darker po ng samples. And may sinasabi po sila doon na Lexington limestone. Yun po yung biggest commercial boom po na marami pong oil and dark po. And then sa pag-dip nga po, sa deeper po ng samples, kuha po tayo ng real clean na limestone which is called Black River po. Yun po yung mas fine shale. And yung bentonite naman po yung nasa pagitan po ng Black River limestone. And ang tawag po dun sa parang layer na yun is concave po. Ayun po. Tapos may from mga 4,000 more feet, meron pong predominantly shale lang. Tapos may mga interbedded din po. Ayun po. Tapos dun po sa madlag nila, naka-plot po lahat with from name, area, location, ayun po, hanggang sa lithology and legend. Yun po.
Okay, so, sino pa? Sino pa? Wala nang gusto mag-share? Yung dress.
Ma'am, na-share na po ba yung sa ginagawa po ng madlag?
Actually, yun naman talaga is ginagawa ng madlogger. What I am asking you is kung ano ba yung learnings ninyo
Okay,
about
sige po.
the video.
Baka lang po nabanggit na. So, yun nga po. Ang isi-share ko po ay yung natutunan ko po about po sa ginagawa po ng vlogging yun. So, meron po tayong tinatawag na geosampler or sampler counter po. Sila po yung po gaano po ng mga photographs po na nakuha po sa mismong area po. And then, we have vloggers po. Ano po sila po yung nagmo-monitor po ng ating oil well leak. At saka po, iba pa pong combination po within the unit po ganun. Tapos po third po ay meron po tayong data engineer. Sila po yung ano po, nagpe-prepare po ng kumbaga po continuous improvement po ng mga iba't ibang klase ng well log po reports na kung saan doon nakalagay yung mga data po na, nag, na naglalaman po ng pinaka-final work po nila about sa oil well drilling.
Okay. So, next question. So we have yung tinatawag nating major components or parts of your, in madlogging, I mean. The major unit and components of madlogging. What are those? Yung lima. Ano yun? Zamyudo. Zam...
Try lang mo. Ito po ba yung ano, rig floor, mud
Yeah.
tank,
Oo,
mud
oo.
pump, shale shaker, at saka
Again.
trip, rig floor, mud pump, shale shaker, trip tank.
Tama yung tatlo, pero yung dalawa hindi. Sino makakapagsabi? Danila.
Yeah, I think ano po, ito po yung rig floor, mud tank, shale shaker, mud logging unit, ano po yung MWD or LWD unit.
Okay na?
Opo. Narinig ko pa naman.
What is the purpose of mud logging unit? Dalisay.
Ano po ma'am, sole part po siya ng rig, tapos hindi po makakapag-start po pag wala pong mud lugs. I mean, hindi po makapag-start ng operations po pag walang mud lugs.
Another answer? Wala na bang ibang gustong tumaas ng kamay? What is the purpose of mud logging unit? Meron tayong, actually, the main purpose, we have three. Yung pang-apat naman, ano lang yon sa stages. Dadagdagan mo, sagot mo, dalisay.
Apo ma'am, yung nandun po ang sampler or sample capture, sila po ang nagpo-photograph po ng sample by microscope. Tapos
Photograph
ang
agad?
ah ay sila, yun po ang nasa notes ko po ma'am. Yun po, sila po ang
Tatlo yon. Ay, apat pa nga eh.
Apo, yung mud loggers po, tapos yung
Hindi, I mean yung
data.
ginagawa ng geosampler, apat yon. Hindi lang
Ay,
sila nagpo-photograph. Una, sila ay nagko-collect. Padalawa, piniprepare nila yung samples. Patatlo, dinidescribe. And then yung pang-apat, saka pa magte-take ng pictures using microscope. O, ano yung sunod? Geosampler. Tapos, Dalisa, kinakausap
ano po,
kita.
yung mud logger po, monitors oil well drilling operation. Sila pong nagko-connect po ng branches like drilling and mud engineer. Sila po nag-maintain ng connections po dun sa drilling and mud engineers po.
Mhm.
Tapos ang pangatlo po ay yung data engineer po. Sila po ang nagpe-prepare ng different kinds of well log reports po. Sila po ang may most important role po dahil dun po sa log reports ang full rig data po. Tapos yung pang-apat po yung all stages work simultaneously po.
Okay. So that is the main purpose. Why it is important in an rig site to um, to build a mud logging unit. So ngayon, wait lang. Let's proceed to our discussion today, which is about Cory. Okay, so nakikita? Can you see?
Opo, ma'am.
Okay. So ano nga, pag sinabi natin coring, what is coring? What is coring? Coring is about Lumbres.
Kung hindi po ako nagkakamali, ang coring po ay yung pagtatanggal po ata ng mga rock sample po sa ating pong oil well.
Hindi ka sure? Ha? Hindi ka sure?
Yung coring po, yun po, sure po.
Makaraeg.
Yun, yun yung kwentuhan po ng para pong sample po na sample po sa borehole po then ito po yung itinetest po for lithology po nung hinuhukay po ng well.
Okay. So, coring, when nakarinig kayo ng word na coring, so ibig sabihin dito nagaganap yung tinatawag nating collecting of core samples, and analyzing them to provide us informations we need to know about the condition, of our borehole. So, what is coring? Ano, so, sabi dyan, ito lang ay parang pinaka-specific definition or broadened definition of coring. So, it is where pores which extract from the formation or reservoir using special coring tools. Once the cores are cut, they are captured and retrieved to the surface for analysis of different physical parameters. And based sa mga sinabi natin kanina, so it's just the same definition as what it is written here. So, oil well coring is a procedure that is meant to remove a small amount of rock sample. Bakit small amount even though yung measurement na sinabi natin before is about 50 to 60 feet? It is still a small amount because compared to the reservoir we have beneath the surface, it is just small. Okay? So this entails using a core bit to drill and remove a cylindrical sample of the rock. So yung ating core sample, it is usually having a shape of cylinder shape. So the core bit is used with a core barrel and core catcher to drill out a sample that is then brought up to the surface with the core barrel. Okay, when we say core sample naman, as a definition of core sample, it is a cylindrical section of usually a naturally occurring substance. So the most core samples are obtained by drilling with special drills into the substance. So for example, so we have a sediment or rock. So with a hollow steel tube, using a hollow steel tube called the core drill, so pwede tayong makakuha ng core samples doon sa sediments or rock na iyon. So the hole made for the core sample is what we call the core bowling. Mamaya papakita ko sa inyo kung ano yung tinatawag na hole. Yun yung tinatawag nating core bowling. So a variety of core samplers exist to sample different media under different conditions. And then meron tayong dalawang type ng core sample. So we have the disturbed sample and the undisturbed sample. Okay, so what is the purpose of coring? Bakit ba natin ginagawa ang coring? Or bakit ba tayo nagko-collecta ng core samples? So first is for making reservoir analysis test to determine porosity, permeability, residual oil, and water saturation. So paulit-ulit na lang tayo dito. And these parameters are yung tinatawag nating primary purpose of coring. So, next is to establish the physical character of formation boundary. Boundary yon, boundary. Third is to furnish paleontological data for age and phasis correlations. Kasi pwede din natin yang gamitin dun sa tinatawag nating geologic data. And then lastly is to determine the structural attitude of the beds. Kasi nga sabi natin, Kaya tawag dyan ay structural attitude. It is because our rocks, ano, can can behave depending dun sa kanilang want, kung paano nila want mag-behave. And we can control that naman. So that's why we need to monitor them. So at least, um, pwede natin siyang magawa ng paraan para at least maging stable. Pero, ayun nga, those ways para or para ma-prevent sila from behaving too much, ano, edi gumagamit tayo ng mga alternative chemicals. Okay, so let's discuss or describe what the scoring method is. So sabi dyan, the scoring procedure should follow a systematic approach. So kapag sinabi natin systematic approach, ano ba pag sinabi natin systematic approach? From the word systematic, kabali.
Kapag po sinabi nating systematic approach ay may sinusunod po siyang step by step process po.
Okay, so may sinusunod na step-by-step process. Or, it is referred also as a rule-based approach. So, meaning, meron na tayo sa dyang steps on how we do coding. And we cannot do coding if we're not going to follow that steps. Kasi kapag hindi natin yung sinunod, it is possible na meron tayong or ano bang tawag doon? Pag hindi natin siya sinunod, it is possible na magkaroon ng problem. So that's why it is said that we should follow a systematic approach there. So the water depth should be measured using an echo sounding device. Ano yung echo sounding device? Wherein we are using sound waves. That is, anong device yung gumagamit tayo ng sound waves? Sino yan? Hindi ko makita. Cappuccino.
Sonic po or acoustic lag po.
Okay. So, the tool that we can use, to have this echo sounding device, wait lang, is yung ating sonic lag. Sino ngayon sumagot? Cappuccino nga, tama ba?
Yes po.
Okay, so sabi, when coring, a dual or triplicate core approach should be used to cover boundaries between core sections. So since we know that the rock is so tough, so the core bit or drag bit in some cases uses a PDC or natural diamond cutting device to cut with. Kasi sabi nga natin, so the main reason why they use diamond as the main cutter, for the drill bits, kasi nga, hindi naman natin masasabi na yung rocks natin dun sa ilalim is, siya, medyo malambot. And since diamond is known as the hardest type of material that can cut anything or everything, so yun yung kanilang main choice na gamitin as their material. So when the cylindrical sample is cut out, it needs to be safely removed from the well. So that's why our core barrel is what? Our core barrel is ano nga ulit para may angat natin ng safe ang ating core sample? It is, ano? It is covered with, it is covered with what? It is covered with resin. So the core catcher device grips the bottom of the rock core, Tension is then applied to the drill string and this causes the rock core sample to break away from the rock beneath it. So by holding the core sample, the core catcher serves to prevent it from falling away and being lost. So hindi natin kailangan na iasa na lang sa ating core barrel or dun sa mga tools yung ating tawag dito, yung pag-angat ng ating core samples. So we should observe or maintain or watch it carefully and provide a core catcher for it if ever na siya ay um, malalaglag. Okay, so normally the most important information desired from the coring operation concerns so these are the informations na talagang gustong-gusto nating malaman using core samples. So first is the porosity, which is a measure of a fluid carrying capacity of the formation. Permeability, which indicates whether the formation fluids will be able to flow at rates fast enough to permit economical production of the hydrocarbon fluids. So we can also obtain information about the water saturation in our formation. So paano natin malalaman ang water saturation? So sabi ko nga sa inyo, since our core samples, it may be porous and permeable and impermeable, it is possible that there is a presence of fluid na kasama ng core sample natin. And lastly, hydrocarbon saturations including the relative percentages of oil and gas. When you say relative, so that is not the total amount of oil and gas dun sa reservoir. So, meron tayong tinatawag na rotary coring. So, yung rotary coring natin dyan, so it is an equipment that has continued to keep abreast of technological developments in drilling industry. And at the present time, meron tayong tatlong types ng rotary coring equipment. So first, we have the conventional coring. Second is the wireline retrievable coring. And the third one is the diamond coring. Bukod pa yung sidewall coring. So, dito tayo sa next definition. So, when we say conventional coring, it is a method of drilling and acquiring rock samples to retrieve the core samples. So, syempre, lahat naman ng ating ways or methods of coring is to retrieve core samples. Pero dito, in conventional coring, they use complete rod string and core barrel assembly. They use complete rod string and core barrel assembly has to be removed from the hole. So yun yung conventional coring. And sabi ko nga sa inyo, in conventional coring, we just provide the basic information that we can get from the core sample. Kapag naman wireline coring, so, yun, again, coring is to obtain samples of different rock types. So, dito naman, the assembly used for a core drilling crown consists of a sleeve reamer. So, ang gamit naman ni wireline coring ay sleeve reamer. Okay, so kapag naman sinabi natin diamond core drilling, so from the word itself, diamond, so it made of diamond faced coring bit, and then itong diamond bits may be also used to advantage in coring hard, dense formations where the cost of the coring with roller cutter bits is high. So yan yung best option that will be used if kukuha tayo or magkukollect tayo ng core samples or we do coring. Kasi ang kanyang material is in diamond na. Mamaya, papakita ko sa inyo kung ano itsura ng mga diamond core drilling na yan. And then, meron tayo ditong another coring method, which is the sidewall coring. So, it is a supplementary coring tool. It can be used in zones where core recovery by conventional or wireline method is or in zones where the latter cores were not obtained as drilling process. Ano? So, sa sidewall coring, ano nga yung ginagamit nating tools? We used what? Ha? We used what? We used? Sino yun? May tumaas ang kamay. Ano ginagamit nating tools sa sidewall coring? Kabali? Tama ba? Ay, hindi pala. Sino yun? Yung ano, di ko kasi makita apelido. Christine Ann, Cappuccino.
Coring gun.
Ano, so inside wall coring, we use coring gun. And this is, most cheaper, more cheaper, or cheaper pala, redundant. Cheaper than the diamond core drilling. Okay, so ito so these are the core drilling techniques. Meron pa tayong tinatawag na oil field drilling. So ang ginagamit lang sa oil field drilling is yung oil field core bit, which is ang kanyang curve ay thick. So ito, sabi natin kanina may tinatawag tayong core, ano nga yun? Nasa na yun? Core bowling. It is the hole made for the core sample. So ito yun. So ito, this is area to be cut. Ito yung sa oil field drilling core bits. And as you can see, dahil mas thick ang kanyang curve, mas malaki. Yung area na nakakat. And this is what we called our core bowling. Bowling nga? Bowling nga. Core bowling. Tama? Hindi niyo ako sinasagot. Tama. Core bowling. And then, ito, yung ating core sample. Pagdating naman kay diamond core drilling, since meron lang siyang thin curve, and it used diamond core bit, so itong maliit na ito, yun lang yung kanyang CD. And itong nasa gitnang ito yung ating core sample mismo. Naintindihan?
Yes po.
Naintindihan? Okay, so these are the types of thick curve rotary core bits na ginagamit sa ating tawag dito sa ating core bit. Ayan. So ito, the surface set diamond bit. So yan, mga diamond yan. Ito PDC. Diamond bit din yan. So we have here the used in KTBBV. Meron tayong 4 roller cone bit and 6 roller cone bit. So ayan, this is our diamond wireline core bits used in KTBBB. Ito naman, pag walang wireline, so ganito yung kanyang itsura. Ayan, these are the diamonds, yung mga bilog-bilog. Ayan. So that is our diamonds. Ito din, nasa gilid ng diamonds. Ay, sobra. Okay, so look at this figure. So this is our core sample. So this is our CF. And sabi natin, core sample are slabbed or cut lengthwise. Kasi nga, anong sabi natin kung bakit lengthwise ang paghahati ng ating core samples? Yes, Christine.
Kasi po ay kapag po yung clockwise po, possible po na yung outside part po ng core sample ay exposed na po sa different substances outside po. So, alter na po yung parang pinaka-property po ng sample.
Okay. So, bale, ang mangyayari dyan, it is slab. Meron tayong mga thin sections, small samples, and yung malaking part. So, ang slab core, ano? So, it is used for photography, sedimentology, lithology, and samples. Ano, so paano makuha yung slab core? So, from this government or regulatory body, ano, so ito yon. This is our government or regulatory body, itong malaking part. Sampling, itong gitna, and then curation, itong dulo. Yan ha, may arrow. So, itong sampling natin, ano, yun yung paggagamitan natin ng slab core. And then, itong curation natin, at pati pala itong small samples. Dito natin siya kukunin sa sampling dito sa padalwa. So, yung small samples, ano, small samples are used to determination of grain size distribution, mineral analysis, X-ray and SEM analysis, and biodating association. So, ito namang curation, yung pinakamaliit na part, ano, so, ito ang ginagamitan niyan ay itong thin section. So, ang anong makukuha natin sa thin sections? We can get the detailed pore structure, the diagenesis, the porosity type, and the environmental evidence. And since ano, meron tayong malaking part dito which is called government or regulatory body, madami tayong pwedeng paggamitan yan. Ano, so we can use a routine core plug analysis which we can get the porosity, permeability, grain density, and as received saturation. We can also use it for a special core analysis. Ano, so ito yung ating makukuha dyan, preserved restored state, capillary pressure, relative permeability, electrical properties, acoustic properties, compressive properties, clay chemistry effects and specific tests, and lastly is the calibration of wireline plugs. Ano, so ganyan hatiin ang core samples para ma-maximize ang kanyang sukat in different kind of tests or analysis that we need to do to obtain our needed information. Okay, so this is just a sketch of coding bits that we use ano, in collecting core barrels. Ay, in collecting core samples dun sa baba. Ano, so this is for conventional core barrel. So, ganyan yung itsura niya. And then, ito yung ating diamond core barrel. As you can see, mas malaki ang ating diamond core barrel. Ay, mas malaki, mas thick ang ating conventional core barrel kaysa sa ating diamond core barrel. Okay, so this is, ano naman, since nakapag-provide tayo ng conventional core barrel at saka diamond core barrel, so we also have here a representation kung ano ba ang itsura ng ating wireline core barrel at saka core barrel detail mismo. Okay, so let's proceed to the core handling process that we have. Ano, so nung una, sabi ko sa inyo, this core handling process is included in dun sa tinatawag nating core preservation. So sabi natin sa core preservation, meron tayong tatlong ways to preserve our core samples. What are those? What are those? Anyone? Mark Lawrence.
Ma'am, try lang po. Ang una,
Ilibo.
Abrahan po, ma'am.
Okay.
Ang una po ay core barrel is filled with resin to prevent from the core from moving and to minimize the exposed surface. Ang padalawa po ay freezing the core in the freezer containers. Tapos po ang patatlo ay core sample is wrapped in a plastic film, aluminum foil, and then deepen in the molten wax po.
Okay. So those three, ano, are some ways to preserve the core sample. So ito, ano, so let's have here the core handling process. So first daw, ano, we should prepare adequate number of boxes having rags. So dun sa boxes na yon, may nakalagay na rags, and then after we collect or after the core sample is delivered to the surface, dun natin siya ilalagay. Ano, so these boxes should be set up dun sa ating tinatawag na rig floor to to receive the core. Alam niya na naman ng read core, di ka tinuro ko yun kahapon. Next is the supervised core layout to ensure correct orientation and order. So, ano yung tinatawag natin correct orientation and order? It is because, so we are collecting core samples depending on its depth and time. Next is we should wipe core clean with clean dry rags. Okay, kasi most likely siya ay filled then or exposed to some muds because our borehole is surely ano, having a presence of muds there. Next is to fit core, space rubble between ends of core, put rubble in sample bag and mark depths. Next is to provide strap core, uncovered interval understood to be at bottom unless known otherwise. So if ever na meron tayong mga uncovered interval, so it should be face the bottom of our box. Next is to mark core with reference lines and depths using marker pens kasi nga, ang pagkukulag natin ng core sample is depending on the depth of our borehole. Next is to describe the core and shows. And then lastly is to box core and mark boxes. So saka natin ipoproceed yung freezing at saka yung pag-dip ng ating core sample sa mga molten wax. Okay, so let's proceed now to the importance of coring. Bakit nga ba importante ang coring? So ayan, nag-provide na ako ng pwedeng yung isagot kapag may tanong na what is the importance of coring. So coring provides the only valid representation of the formation because may kakaroon tayo ng contact with the original rock types of our formation beneath the surface. Kasi nga, kukuha na tayo ng core samples. It's the only means of direct measurement. All other methods such as well logs require interpretation, while conventional well logs play an important part in reservoir identification. So only coring can ensure reliable correlation of those logs to the actual subsurface conditions, and for the most advanced analysis, only core samples can yield critical data such as porosities, permeabilities, and saturation. They understand the importance of coring.
Yes po.
Okay, so that is all for coring. Proceed tayo sa drill stem test. Pero before we proceed, break muna tayo ng 5 minutes. 5 minutes lang. Okay, sorry guys. Naririnig niyo na ako ulit? Ha? Naririnig na ako ulit?
Opo.
Okay, so let's continue our discussion. So we have the drill stem test. And kung mapapansin nyo, ang title ng ating chapter 3 ay Mad Logging, Coring, and DST lang. Pero sinundan ko itong DST, kung mapapansin nyo sa ating manual, sinundan ko siya ng parang pinaka um, introduction ng ating seismic interpretation. Ano, para para in preparation dun sa ating next chapter, which is medyo madami-dami. Dami-dami. Duda na ako na matatapos natin yun today. Okay, so proceed tayo. So this is the drill stem test. So for the outline of this PowerPoint, let's discuss what is DST, why we should use DST, what are the tools of DST, and how DST. Pero yung tools na nandito dito sa PowerPoint, kaapat namang iyon. And then balik tayo dun sa, kasi yun yung basic, hindi pa basic. Yun yung usual tools ng DST. So yung basic tools ng DST is nasa manual ninyo. So, pupunta tayo sa manual later and then i-discuss natin. Okay. Okay, so let's have first why DST. So, kaya ako isinunod ang ating seismic interpretation is because, DST uses seismic survey. So the seismic indicates the possible existence of the potential reservoir. So, ayan, pababa ang sa ating signal. And DST indicates the well deliverability and its worthiness of completion. So that is the importance, or that is the reason why we should use DST. So ito, data. The data can give us knowledge, and the knowledge, it can give us the ability to prove. So in DST, we can now get the capacity, the pressure, the permeability, and the extent of reservoir. Okay. So now, let's define DST. So when we say DST, it is a temporary completion of a well bore that provides information on whether or not to complete the well. So dito, so ayun nga, drill stem test or DST is known as a temporary completion. Yun talaga yung pinaka-keyword when it comes to DST, temporary completion. Okay? So it consists of a combination of packer arrangement and drill pipe or tubing. Kasi nga drill stem. So, meron din tayong presence ng valves in this arrangement to open and close the tool, and pressure and temperature recording devices are employed. Actually, we have different kind of valves that we can use when it comes to DST. Pero, ang inilagay ko lamang dito ay auxiliary valve, and yung auxiliary valve is may two types din. So, ayun lang. Ay, dalawa pala. Kasi may tester valve pang isinama ako. Kunin ko lang, wait lang. Kunin ko lang yung itsura ng tester valve at saka auxiliary. Meron kasi ako nun, hindi ko lang nalagay sa PowerPoint. Ilalagay ko lang. Wait lang.
Magkaiba ang epekto niya. Bakit magkaibang epekto? Alin ang mas malaki ang power na kailangan? Siyempre, yun nag-a-account. Alin ang kakonte, yun nag-lulusaw. Now, so yung
wait lang.
pinakasalubin dati, formulang na rin. Ayan. Yung ating effective tension, kung hindi natin po consider yung mga kuwan, That is T1 minus T2. T1 minus T2. Tight side and slack side. So yung ating rough factor that is equals to 1 over e to the f theta minus 1. Saan yung pinakasalubong natin? Yung T2 over effective tension. Nakasalubong natin yan sa machine design kung tayo i-design ng belt. Yun. Sabi diyan, yung rough factor, makikita rin natin din sa table. Nasa table na yan, yan yung ating mga rough factor. Meron tayong tinatawag na single or no snap, single with snap, mayroon tayong dual. Alin ba yung snap? Yung parang kanina, si Andrea, tinatawag natin, hindi nasa doon. Yung snap yun. Yun yung snap, yung pinakadulong idler na katabi ng uli. Ano? Uli ang tawag natin doon sa dalawang dulo na idler. Dalawang dulo na conveyor. Yung pinakadulong iyon, di ba? Ano may pagpabiling idler, may pagpabiling idler. Yung pinakahuli, yung mga pinakahuling yan, ano, yan yung snap. Now, sabi niya, may nakalagay no snap. Ang assumption mo doon, ano, ang rap ko niya, tinanggal mo rin. Diba? Tinanggal mo rin aring snap ulit. Ang rap niya, ang in contact dito ay 180 degree. Kapag single snap, isang gayong laak, that is equal sa 240 at 210 lang, equal sa 210. Kapag dalawang snap, ano, naglagay ka pa din pinay mo pa din That is, maximum niyan ay 380 degree. Yung in contact. Ano? Pero ang paggamit ng snap, bakit ba tayo gumagamit ng snap doon sa ating kuha? To increase yung wrap. Yung pagkakaikot doon, yung angle of contact ang tawag natin ng takuan. Dito tayo nagmamachine design. Para yung lapat ng iyong belt. Pero may limitation ang paggamit na snap. Una, snap pulley diameter is limited by belt specification. Ano? In order to thread through a new replacement belt between the pulley a suitable clearance. Hindi mo yung kaya ikuha kasi
Okay.
meron ka mga idler, lalapat na yun sa kasunod na idler. Yung iyong return belt, pag kinuha mo pa yan, then, another
Okay, so ayun,
implementation of belt.
DST is known to be done after installing the casing and before hooking up the well. So, yun, yung pinaka-exact point or
Para sa
ideal,
dual pool, ano ba yun?
ano ba tawag doon? Ideal,
Ito yung mga tinatawag natin
or yung
dual
pinaka-tsempo,
pooling.
yun na lang, yung pinaka-tsempo para
Dual
gawin
pooling na
yung
yan.
DST natin or yung drill stem test.
Ay pupunta
So,
sa
if
effective
you get a
station.
good DST, so we can get the fluid samples, the reservoir pressure in P, the formation properties including permeability, skin, and radius of investigation. So actually, we have here the
Secondary and
computation
primary.
for skin and the radius of investigation, pero hindi ko na siya
T1
isinama.
minus
And we can also get the productivity estimates including flow rate, Q.
So, ang total
So the analysis of the DST transient pressure data can provide an estimate of formation properties and wellbore damage. And this is ano, the illustration of components of the drill stem test tool including both surface equipment and downhole tool. So, ayan, ayan. So we have, ito yung ating drill pipe. We have here the handling sub and choke assembly. Ayan, these are the tester valves. Ito. So this is our drill stem. Ayan. Meron tayong presence ng anchor pipe, safety joint. Ayan. So ito yung pinaka-actual and then ito yung anong tawag dito? Ito yung ating kung paano siya ibinababa sa borehole. Kasi ito yung gilid. Ano, ito lang is yung parang mas magandang illustration of the drill stem. Okay, so what should we do before we start the DST? So first, we should plan. So the key to successful testing depends upon planning and teamwork between the JU scientists and the engineers. So potential pay zones, yung tinatawag nating potential pay zones, ibig sabihin, ito yung mga zones kung saan possible tayo makapag-produce ng oil and gas or hydrocarbons na makakapagbigay sa atin ng payback. Should be identified before drilling commences so that the drilling program can be designed to accommodate the test. And then next, after planning, we should also have the safety. Kasi, diga, risky naman palagi.
Halimbawa, nandito ang motor mo. Nandiyan yung iyong motor. Binabatak ni Lare. Yun ang kwento niya binabatak niya na rin. Ay tubig siya gilid total na nakalagay.
Okay, so for the safety, so we should take note of this. Running a DST is one of the most dangerous jobs in the oil field because the well is essentially uncontrolled during the test. All firefighting equipment and the blowout preventer should be inspected and tested before starting a DST. Kasi when we do DST, so ito yung method na kung saan mas possible ang blowout natin and also the explosion. Kasi meron tayong presence ng hydrogen sulfide or yung H2S. So hydrogen sulfide equipment should be on hand if anticipated conditions are sour. Kasi may tinatawag tayong mga sour sa reservoir. So no test should be initiated at night or during an electrical storm. And this is most important, no smoking should be allowed on the drill floor or near any flow lines or surface test equipment.
Natatrabaho lang talaga, 182. Yung isa, natatrabaho
Okay, so how we do DST? So it is done in 4 stages. So we have the A, B, C, D. Ayan, ito. This is the representation. It is a typical pressure profile observed during DST test. It is pressure versus time. So for the short production period, we have the initial flow or yung IF, and initial flow is done within 5 to 10 minutes. Ito yon. Dito sa part na to. So dito nangyayari yung tinatawag nating initial flow. Next, short shut-in period or yung ating initial build-up or IBU. And it is done, after 30 to 90 minutes, dito naman, ayun. Okay, so next is the longer flow period. Kung meron tayong short, syempre meron tayong longer kasi mas matagal na yung ating time dito. So the longer flow period or yung ating final flow or FF, it is within 1 to 5 hours. After 1 to 5 hours, dito siya nangyayari. So kada may flow and then build up tayo, our flow is bababa, build up tataas, flow bababa, build up tataas. And lastly is the longer shut-in period or yung ating final build up, FBU, which is about 3 to 10 hours. So ito yon, gigit na siya dito, 3 kasi 3 hours, 3 to 10 hours. Ayan. So that is how the ST is tested within this hour. So, ayun, hindi ko na din isinama
Speaking of that, hindi
ang
naman laging fluid ang arrangement
tawag dito,
ng
solving in
conveyor.
initial build-up. Gusto niyo ba?
May conveyor tayo na ganito.
Gusto niyo ba isama pa natin?
Single pulley drive. Magkapantay ito, 180 gram.
Ha? Gusto niyo? Sasama natin ang
Pwede
computation?
ganyan. Pag may
Or
center
wag na?
yan, pag medyo bumigat, single pulley,
Uy,
iniikot
naririnig niyo pa
natin
ba
ang
ako?
surface, ang rough angle o yung contact.
Hello?
Lagyan natin ang isang doon. Then another, ayan. So
Ano pa man?
yung kanina ay
Naririnig niyo ako?
Hindi naman, may snap ka, dapat balikan pa lang power.
Yes.
Opo, naririnig.
Sasama natin, hindi.
Yan.
Ngayon pong discussion.
Okay, then tuwid pa ang palusula.
Kung tinatanong ko kayo kung gusto niyo isama yung computation or wag na.
Then, etong isa, pwede
Hindi kayo
ganyan.
sumasagot.
And then,
Okay, so let's proceed to the those tools of DST. So, these are the main tools that the DST have. So, we have the drill string, the packers, the
ganun
testing
pa rin
tool,
ang
and
pagdaan tayo ng
anchor
mga
pipe.
drive,
So,
pulley,
ayan.
may pulley tayo. So, yun isang
So, ayan. Testing tools and packers are mounted below the drill collars. So, the packers are here sa baba. Below the testing tool, a perforated pipe or yung tinatawag nating anchor pipe is mounted. Hindi dito yun. Hindi dito sa baba. So inside the anchor, an upper pressure gauge is situated above perforations, reading pressure below the testing tool. And then, doon naman sa baba ng anchor pipe, dito, another pressure gauge, which reads the pressure in the annulus between the sun face and anchor pipe. Okay, so this is an example of a test valve. So, when we say test valve or yung ating tinatawag na tester valve, it is the major role in drill stem test. It is placed in the upper section of the DST tool above the hydraulic bypass valve. Tingnan natin kung meron dito. Ito. So nandun din siya sa pagitna. And ganyan yung kanyang itsura. Ito. Ganyan yung kanyang itsura. So according to Black, during 1956, it is one of its main function is to provide to provide a passage, since this is a valve, for fluids to flow into the drill pipe when the packer is set at the annulus. Second, it prevents the drilling mud to enter the empty drill pipe. Kasi when we say valve, it has the ability to open and close. Tama ga? Tama?
Opo.
So it opens to provide a passage for the fluids to flow into the drill pipe, and it closes to prevent the drilling mud to enter the empty drill pipe while running in the borehole. So it also assists in the prevention of drilling mud entrance to the drill pipe while pulling out the DST tool assembly, and aids in the conservation of the recovered reservoir fluids to the surface. So ito naman, yung ating example ng packer. So ngayon, proceed muna tayo sa manual. Wait lang. Hindi pala naka-open ng manual sa akin. Sandali.
Sabi niya kung sino daw ang forward. Wait, ano ang kapatid?
Kaya kasama na.
Nakakuha na ka sa Chancellor?
Okay, so let's discuss the
Dahil
basic
sabi sa akin
tools
ni Chancellor daw
in
magpapawan.
the ST. And real-time testing can be divided into two main categories. So we have the open hole and hook wall. So, ito, starting at the bottom of the string, the most common. Testing tools and other main functions are as follows. So, we have the blank off pressure recorder. Ito yung nasa pinakailalim, nasa baba ng, ano nga yung nasa baba? Nasa baba siya ng anchor pipe.
Balik
So,
tayo,
yung
ano?
ating outside
So, ito pa rin
gauge.
din lang.
So, it provides a step-by-step graphic story of the real-time test since it is a recorder. So, ire-record niya yun by comparison with other gauges in the string. Kasi meron pa tayong isang gauge which is inside the anchor pipe. So, anong tawag doon? Upper pressure gauge.
So, ito,
Ano? So, it will reveal the proper function of the testing string. No flow of fluids from the formation passes by this gauge. Consequently, all pressures are recorded directly from the annulus below the packer. And for the fluids to not flow here, so tester valve or sa test valve ang bahala doon. Next is the perforated anchor. So, itong perforated anchor natin is yung ating tinatawag na anchor pipe. Okay, so it supports the testing string and keeps the packer seated in the wellbore. So yun yung kanyang purpose. So the anchor is provided with the small holes, and the holes is approximately 3/16 inches, 3/16 inches only, to allow passage of formation fluids and to screen debris that might otherwise plug the fluid passages in the tool. So, hirap naman. Kita niyo yung figure kanina? Meron siyang butas-butas.
nakita mo, nandito yung kanyang driver.
Pinagbasdan niyo ba yung figure kanina?
Meron din siya. Driver din sa kanyang head.
Ha?
Meron siyang driver din Meron siyang
Or hindi? So, mamaya balikan natin. When we say packer assembly naman, it provides a bridge in the wellbore between the drilling fluid, so yun yung purpose ng ating packer assembly, and the zone to be tested. So the hydrostatic head is withheld from the formation by means of the packer. So, itong ating flow stream gauge, ito yung ito yung upper pressure gauge na nasa loob ng ating anchor pipe. So, the purpose of this, so it also will give a concise picture of the testing operation. So since this is gauge, nagre-record din yan. So, this pressure recorder is placed in the flow stream above the packer and below the tester valve. All pressure fluctuations must pass through the perforated anchor to reach the recorder. And then, ayun nga, we have the tester valve. And then, meron pa tayong isang gauge.
kahit madami ang papalagay
Ayan
sa
pala,
market,
meron pala dito.
kahit madami ang papalagay sa
Ayan, so
market,
ito yung ating perforated anchor. So, may mga butas-butas yan.
bago mo itakbo, binabawasan
Medyo
mo
visible. Medyo visible ba sa inyo?
binabawasan ang
Ha?
Hindi po masyadong mabasa yung label po.
Pero nababasa nyo dito.
may mataas, may
Sa
mababa.
screen.
Ano mangyayari doon? Yung tension ng yung
Sige, isa-isahin natin. So, we have also the air chamber gauge. So, generally is run inside the air chamber on test where an initial closed-in pressure is taken. So, ang kanyang most likely na nare-record ay yung initial closed-in pressure and provides a means of checking the air chamber for fluid entry prior to the opening of the tester valve. Kasi diga ino-open natin sa tester valve para pumasok yung ibang fluid. So, lastly is the auxiliary valve. Auxiliary valve is nasa taas. It is placed at a distance above the tester valve. Ito yung tester valve natin kasi. So, medyo distant lang siya ng isa. Kasi ang nasa pagitan nila ay yung ating air chamber gauge. So it provides an air chamber into which compressed mud below the packer that can expand when the tester valve is open. So, yun yung purpose ng auxiliary valve. Nakakompress niya si mud so that the mud or the draining mud will not go into our stem or dun sa loob. So these methods allow the pressure beneath the packer to drop below reservoir pressure, followed by a rapid buildup of the formation pressure prior to any appreciable amount of production. And ito yon. Ito yung ating dropping and buildup of pressure. Ayan. Yung itinuro ko kanina. So, ito kung hindi masyadong basa sa inyo. Itong taas natin, this is a drill pipe. This is a drill pipe. This is an auxiliary valve and or circulating valve. This is our air chamber gauge. So usually this is just an optional part of our drill stem. Next is a tester valve and a bypass valve. And then next we have the flow stream gauge. Next is the optional tools that we have. We can have jars, safety joint, and many more. Next is the packer assembly. Next is the perforated anchor or yung tinatawag nating anchor pipe. And then lastly, we have here the blank off gauge. Nasundan? Nasundan ba?
Opo.
Okay, so let's proceed to the two types of auxiliary valves. So sabi ko nga sa inyo, meron tayong different kind of valves within our drilling stem or drill stem. Pero pagdating kay auxiliary valve, meron tayong dalawa. Even though siya ay optional na ilagay, meron tayong two kinds of auxiliary valve na pwedeng ilagay. First is the disc valve. So it is consists of a steel body with a fluid passage blanked off by aluminum disc, and this type of valve is opened by dropping a steel bar to rupture the disc. So kaya siya tinawag na disc kasi it is consisting of disc that is used to open the valve itself. Next is the rotation type valve. So the valve is run into the hole in the closed position and is opened by rotation. So that's why it is called rotation type valve. So further rotation will again close the valve and provide a final closed-in pressure. Okay, so next we have here the testing procedures that we have in DSP. Okay, so ito ay tatlo. So the first one is what we call the conventional DST. Conventional DST is consists of 4 periods that we can see here also in our figure. So the one is the going in the hole. So ito, pababa. Kaya ang tanawag ay going in the hole since siya ay pababa and also itong isa. Ayan. Nakikita niyo ba yung aking cursor? Can you see? Okay. And then next is flow into the tool, number 2. So ito yon. Ito. 3 is the shut-in period. Ito. When the flow, pag ganun kasi yan, is nakita niyo nagkaroon ng parang curve. So meron tayong flow in, shut-in period, and then 4 is coming out of the hole. So, ayan, ito. Coming out of the hole na yung nasa dulo. So detailed chart descriptions have been treated adequately in the literature. So the increase in pressure during period 1, period 1 is caused by the weight of the mud column. So when the packer is set and the test valve is open, this weight is removed and replaced by the weight of the column. So ito din, meron din tayo ditong presence of weight ng mud column. So, sabi doon, kapag nawala yung weight or yung bigat or yung mass, it is replaced by the weight of the column in the drill pipe being either air or cushion. So, that's why siya ay aangat ulit. Kasi, mas less dense ang ating air. So, the increase in pressure during period 2, yung caution natin mamaya i-discuss natin, we have different kind of cautions kasi, ano. So, the increase in pressure during period 2 results from the increased weight of fluid flowing into the drill pipe. Ano, so yung ating period 2 naman, kung si period 1, ano, it is depending on the weight of the mud column. So dito naman, ano, sa period 2 is increasing weight of fluid flowing into the drill pipe. So at the end of this period, a valve is closed at the tool and further increase in pressure results from the restoration of formation pressure. So the next, the packer is released and the mud pressure takes over. So dito, ano, since nagkaroon tayo ng shut-in period, dito ay si valve ang may kagagawan, which decreases again during period 4 when the tool is run out of the hole. So, next naman is yung tinatawag nating double closed in DST using air chambers. So, sabi dyan, the principle of measuring the initial shut-in pressure is to produce a very small amount of fluid from the formation followed by a shut-in period long enough to allow the pressure equalization. So, yung pressure na mame-measure natin after magkaroon ng shut-in period, ano, is yun yung tinatawag nating true reservoir pressure. So, again, ano, if we have this shut-in period, meron tayong mame-measure na pressure, and that pressure is what we call the true reservoir pressure. So, ibig sabihin, yun mismo yung present na pressure on our reservoir. So the air chamber method, ano, is measuring initial shut-in pressure that has limitations. To obtain a correct initial shut-in pressure representative of the reservoir pressure, our air chamber should be calculated precisely. Again, ano, so in oil and gas industry, we should have accurate measurements. So a reasonably accurate measurement of the borehole diameter is required, and the compressibility of the mud should be known also. Again, yung compressibility of the mud po natin, ano, is si auxiliary valve ang bahala. And some idea should exist concerning the order of magnitude of the reservoir pressure. So this is just an example of initial shut-in pressures obtained by means of an air chamber.
Magpapaalam ka na.
Okay, so lastly, excuse me, kung meron tayong double closed in using air chambers, so ito naman, double closed in DST din, kaso with a flow period preceding each shut-in nga lang. So, ayun, ano, so although the air chamber is still used exclusively in certain areas, many disadvantages of this method led to the use of the method based on two flow periods. So, ibig sabihin, kaya nagkaroon tayo ng flow period preceding each shut-in is because air chamber is um, nakitaan siya ng madaming disadvantages doon sa ating methods. So the principle is just the same, that is, prior to measuring the reservoir, ano, the pressure below the packer is reduced to just a little less than the reservoir pressure. And then, after that, this is now accomplished by opening the tool to flow for a short period. Okay, so the advantages of this method, kasi nga meron tayo nakitang disadvantages kay air chambers, ano, the guesswork is eliminated, and that, if necessary, the reservoir pressure may be calculated from both the initial and final shut-in. And one should keep in mind, however, that is preferably to measure the reservoir pressure rather than to calculate it. Kasi kapag gumagamit tayo ng calculations to know what is our reservoir pressure, nagkakaroon tayo ng discrepancy. So, double closed in DST with the flow period preceding each shut-in, ano, is most reliable since nga, minemeasure na natin ang reservoir pressure and it gives accurate measurement. So the figure below is an example of a two-flow period test. Although the initial shut-in pressure curve appears fairly flat, the initial pressure is less than the final shut-in. So, ito yung ating initial pressure, and ito yung ating final pressure. So, paano ba natin malalaman na mas malaki? Kasi ang ating initial close dito, hindi man kita yung pinaka-measurement, is about 1,518 PSI, and then pagdating natin kay final shut-in pressure, it arises to 1,520 PSI. Ayan, no? Ito. Ito. Ito yung initial. Ito yung final. So for the interpretation, the theory of pressure buildup interpretation and extrapolation has been covered extensively in the literature. Usually, the buildup pressures are plotted versus log 10. Ayan, T plus, anong tawag dito? Degree over degree, where T is the time the tool was open to the flow, and degree is the time the tool was closed during the final shut-in period. So the best straight line is drawn through these points, and this extended to intersect the line for which this formula should be equal to 1. So, ayan. Ito yung mga equations na ginagamit. Actually, apat yan. Ay, tatlo pala. So ito yung kanyang annotations. So it is just presenting to you how to interpret the shut-in and the initial shut-in and the final shut-in of our drill step. Pero we're not going to calculate that naman. Balik tayo dun sa Okay, so ayan nga na. So these are the examples or ganyan yung itsura ng mga packers. So it is just good to know if the well bore is filled with mud. So during the DST, the string is partially filled with cushion. Kapag full of mud, during the DST, meron tayo tinatawag na cushion. So mamaya natin i-discuss kung ano yung iba't ibang cushion na meron tayo. The testing tool isolates the overlaying DCs and DPs from the mud present in the well, and an empty string remain empty as it is lowered. So ito yung ating different cushion. So we have the water, the diesel, the nitrogen, and natural gas. So bakit nga ba natin kailangan ng cushion fluids? So first is to protect the drill string from collapsing. Second is to reduce the inertia of formation fluid as they enter the pipe. So para napipigilan. Kasi kapag yan ay nagkaroon ng malakas na inertia, and inertia is known as a pressure, so dadagdag siya dun sa pressure na existing doon sa ating sa pipe. So baka magkaroon tayo ng tinatawag na kick or blowout. So for unconsolidated formation, pressure exerted by the cushion is about 400 psi difference or less from formation pressure to prevent sand production, gravel pack plugging, and fracture proppant production. So ayun. Do you have questions about drill stem test? May question kayo? Question. Meron, wala. Question po. We have still time, so ating sagadin. Okay, so let's now proceed to the seismic interpretation. So in seismic interpretation, we have here the two methods. We have the passive and the active. So sa passive, it is just measuring spatial variations of static or natural fields of force. So lateral subsurface material variations give rise to spatial variations in the fields, and there is inherent ambiguity in interpretations or we have multiple solutions. So under ng passive method, the gravity, the magnetics, and radioactivity. So gravity, syempre, study of variations in Earth's gravitational field. Magnetics is the analysis of variations in Earth's magnetic field, and radioactivity is the study of natural and induced response to radioactivity. Okay, active methods naman, it is the measurement of wave field characteristics such as travel times of elastic waves and amplitude and pace of electromagnetic waves. So ito ay more on waves. Energy is introduced into subsurface. Given that it has energy, so it is possible that there is also a presence of electricity. So energy, so subsurface, it's the source and detector controlled, and we have less ambiguity compared to passive methods. So ito naman, under naman na active methods, we have also three: the seismology, the electrical methods, and electromagnetics. So seismology, kabaligtaran siya ni radioactivity. It is the study of natural and man-made or man-induced seismic waves. Electrical methods, syempre used of electrical conductivity and resistance of Earth. And then sa magnetics, we are using induced or it is the study of induced electromagnetic fields. So when we say seismic interpretation, it is the science or art of inferring the geology at some depth from the process seismic records. So some of our seismic records, we have the time of arrival of any reflection or refraction. Alam niyo ba yung reflection and refraction? Usually siya ay saan nakikita? Sa? Saan? Yes, kabali.
Ang tanda ko po ay sa mirror po.
Mirror and? Ano pa yung isa?
Kapag po reflection ay water po.
Water or? Kabali.
Well, ang explain ko ga po, ma'am.
Sige, go.
Kapag po reflection, bumabalik. May formula po, pero hindi ko po tanda yung formula. Kapag naman po refraction, kumakalat po yung light. So, possible po sa liquid po yung refraction.
Okay. So, ayun lamang naman ang ating difference when we say reflection and refraction. So, ayun. It is from a geological surface. So, the actual depth of this surface is a function of the thickness and velocity of overlying rock layers. So, the shape of the reflection, which includes, the another seismic records, it contains the seismic records that the seismic interpretation have is the shape of the reflection, which includes the strength of the signal, frequencies, and frequency distribution over the pulse. The frequency distribution over the pulse can give conclusion about the lithology and fluid content of the seismic reflector excuse me, being evaluated. So, ayan, we have the categories of seismic interpretation process. First is the structural seismic interpretation. Next is the seismic sequence stratigraphic interpretation and the lithologist interpretation. Okay, so let's proceed to geophysics. So, geophysics is about geological interpretations made on the basis of these anomalies. Okay, so an incredible 3D seismic line across a structural complex area to the North Sea, ito yun. Once thought to be an impact site, now thought to be a collapse structure. So as you can see, nagkaroon tayo ng waves diyan. So let's just have, kasi ang ating chapter 4 ay about sa sequence of stratigraphy. So let's have a short history about sequence of stratigraphy. So we have here the veil surfaces, define packages of sedimentary rock, so those associated with specific states of sea level are called system tracks. So, ayan. So, ah, anong tawag dito? Ito, ABCD. So as you can see, meron tayo ditong increasing sediment flux. So, kapag sinabi natin increasing sediment flux, so, mas dumadami yung ating numbers of sediments. So, at A, meron tayong accommodation here. Ito sa B, meron tayong transgression. Ayan. And then dito, sa D, meron tayong regression. And due to the increase of sedimentary flux, as you can see, kung ito, there is there is still there is still a presence of fluid here. Pagdating kay D, through time, kumunti na lang yung ating fluid. So, in wave theory, in order to be able to interpret geophysical data, some understanding of mathematical modeling is necessary. Okay, so since we are talking interpreting geophysical data, in interpreting geophysical data, we should use wave theory. And as a mathematical definition, so ito ang ating formula dito. So, meron tayong tinatawag na one-dimensional wave equation, which is ito. It is just a one-dimensional wave equation. So, when a body waves propagates a certain distance from the seismic source, or yung tinatawag nating damage zone, so we have here what we call wave front. So, when we say wave front, this is the surface consisting of particles that all vibrate the same is spherical in form. So, pag spherical, pabilog, so ito yun. So this is our wave front, this is our body wave, and this is our surface wave. Meron din tayong tinatawag na plane wave. So at great distance, the spherical shape of the wave flattens out significantly, forming a plane wave. Okay, so here, since we are talking about waves, so surface waves spread out over the surface and are analogous to ripples on the surface of a pool water. So ngayon, meron tayong dalawang categories ng surface wave. Actually, meron tayong 4 types of waves. Pero dito, dalawa lang muna yung ibinigay, which is categories of surface wave, collectively called L waves. We have the love waves and the Rayleigh waves. So ito, magkakaroon tayo ng further discussions about these waves, and then ipapakita ko sa inyo yung kanilang difference based on their representation. When we say love waves, so these are the vibrations that are oriented in a plane horizontal to the Earth's surface and thus are more purely shear vibrations by 90 degrees. Kaya siya tinawag na L waves. Kapag naman Rayleigh waves, it is vibrate in a vertical orientation, but in combination with forward propagation, forces the particles that comprise the media to move in retrograde ellipse. Okay, so in wave theory, we have here what we call the Huygens principle. Ay, hindi ko lang sure kung tama yung aking basa. Huygens. So, all points on a wave front, so ito, can be regarded as point sources for the production of new spherical waves. So the new wave front is the tangential surface or envelope of the secondary wavelength. So for example, ito yung ating tinatawag na wave front. Ito. So ngayon, they can be used to produce spherical waves. As you can see, nagkaroon tayo ng production dito ng spherical waves. Ayan. Ay, wait, mali. Ito ang ating tinatawag na wave front. Ito. Itong AB, point AB. Ayan. And then, they can be used, as you can see, meron tayo dito different point sources. Ano, ika-copy siya dito. And because in the use of that point sources, magkakaroon tayo ng production of new spherical waves. So, this is just a reflection of the wave front back into the original media. So, we have here the point AB. Ano, so nagkaroon tayo ng reflection. Ano, if the signal is going here, magre-reflect siya dito. So, meron tayo dito parang tinatawag na mirror. So, magre-reflect siya papunta dun sa kabila. And then ito, ano, ganun din, magre-reflect naman siya papunta dito. And then waves, spherical waves are, uh, spherical waves are formed here. Kapag naman refraction, so ito, magre-refract siya papunta dun sa kabilang dimension. Hindi siya dito. Hindi siya magmi-mirror. Ano, papunta siya dito. And ganun din sa point C na nag-refract sa point B. So, ang kanya namang spherical waves dito ay sa baba, kung saan magkakaroon ng um, intersection yung ating mga refraction lines. Okay, so bukod sa Huygens principle, meron tayong tinatawag na Fermat's principle. So, of the many possible paths between 2 points A and B, again, A and B, ano, the ray follows the path that gives the shortest travel time between the points. Ano, so, from point A to B, pupunta sila or tawag dito, yung, yung ray or yung signal from A, hahanap siya ng pwede niyang puntahan, excuse me, kung saan makakapagbigay sa kanya ng shortest travel time papunta sa kabilang point, which is not nakita niya si point O. Okay, so let's proceed to the Snell's law. Wait lang. Snell's law. Snell's law. Okay. So, ito lang sa Snell's law, ano, it's just describe the quantitatively how wave fronts refract or bend at boundaries between contrasting velocities. You've seen it manifest in light waves by the apparent bend of the straw in your glass of water. Light travels slower in water than it does in air. So, refraction is well illustrated using Huygens principle. So, paano? Ano? So, this is our incident ray path. And then, ito yung ating tinatawag na parang mirror. Okay, so ito. Ano, and our eye is our degree. So, ngayon, if the light will go here, sa point, if reflect ang magaganap, ano, so it just mirror its ray of light here. Pero kung siya ay magre-refract, ano, so dito siya sa kabila pupunta. So, this is the refracted ray path. So, in the figure above, I is the incident angle and R is the refracted angle. Ito, ito. Measured between the ray and the line perpendicular to the refracting interface. So, in the example above, the velocity contrast is positive. So, ibig sabihin, V2 is V2 is greater than V1. So, we can now conclude or we can define Snell's law mathematically ano, as this. Ano, so, sine I over V1 is equal to sine R over VR. So, let's have here some of the standard waves terminology. So, meron tayong tinatawag na amplitude, frequency, period, at saka wavelength. Okay, so amplitude is the maximum distance the particles of the medium move from their resting positions when wave passes through. So, ang amplitude natin ay ito at saka ito. Kasi yan yung movement ng ating object. So frequency is the number of waves that pass by each second, and is measured in hertz. So for example, a sound wave might have a frequency of 450 hertz. So yun ay measurement, number of waves. Ano? So period, the time it takes by two successive crests or one wavelength to pass a specific point. So for example, ano? So from here, ang isang wavelength kasi natin ay ganyan. Yan yung isa nating wavelength. So, para makuha natin yung period kung paano nag-travel itong wavelength na ito, we're just going to measure it from here hanggang dun sa dulo ng kanyang wavelength. Yun. So, yun nga, wavelength naman is describe how long the wave is, the distance from the crest, itong top, yan, top, of one wave to the crest of the next wave is the wavelength. Alternately, we can measure it from the bottom naman if gusto nyong dito mag-start. So, kapag dito tayo nag-start sa bottom, ito, so ito yon. Isang wave ito. Isang wavelength ito. Tapos kapag nag-start tayo sa top, so isang wavelength ito. Okay, so next meeting ay next week. Face-to-face tayo next week. Ano? Tama ba?
Yes po.
So, next week na natin ituloy ang about sa geophysical techniques. Titingnan natin kung matatapos natin ang geophysical techniques, proceed tayo sa chapter 4. Okay lang.
Sige po.
Okay. So, do you have any questions? Questions?
Wala naman po.
Okay. So, napag-isip-isip ko na since medyo madami nga yung hindi ko naisama sa inyong manual. And since pinag-isa ko, yung sa chapter 3 lang ha, pinag-isa ko na yung mud logging, coring, at saka DST sa isang PowerPoint, as you can see. Ano, so, ipapasok ko na lang siya before mag-midterm. Ipaalala niyo sa akin sa GC ng class rep. Okay, so if wala nang questions, everyone, so we're going to dismiss our class. Goodbye, everyone. Thank you for attending and participating our class today.
Thank you po.
Thank you po,
Thank you
ma'am.
po.
Thank you po.